All right, so let's do one more binomial probability problem. So let's find the probability of shaking no more than 2 5s from a standard from 6 dice. Okay, I'm going to shake 6 dice. We want to find the probability that we get no more than 2 5s. So what we're saying is we could get 0, 1, or 2 5s. That's what we're looking for, right? Okay, so the probability of getting a 5 is 1 out of 6. The probability of not getting 5 is 5 out of 6. So if we want 0 of them, we put 0, and we have 6 dice. Or, I'm going to come back to the part in front of here. Probability of getting 1 5 would be 1 out of 6 raised to the power of 1 times 5 out of 6. This is not getting a 5 raised to the power of 5. And then one more plus, again, I need to come back to this. There's the probability of getting a 6, 2 6s, excuse me, 2 5s, and then the probability of not getting a 5 would be 4. And again, remember 0 and 6, always, that's how we get to our 6 dice. 1 and 5 gives us 6, 2 and 4 gives us 6. This could happen, though, in several different orders, right? And I showed you can either do permutations or combinations. I'm going to use the combination approach here. So this would be 6 dice, choose 1 of them. This would be 6 dice, choose 2 of them. And this would be 6 dice, choose 0. Again, we could also use the permutations to get that. So that'll give us 0.9377. So go ahead and check that. But I also want to show you how you get this on your calculator. So there's 2 ways. And I'll show you both. In this case, this will be the better approach, okay? But we could do, just for this term, we could go binomial, PDF, which will give us just this probability. Okay, it's going to be, we have 6 dice. Probability of getting our 5 is 1 out of 6. And this is 0. And then we could go the binomial PDF again. Six dice, the probability is 1/6. This time I want 1 of them, plus one more time, binomial PDF. So 6 die, 1/6 their probability, and this time I would like 2 of those, okay? That'll give you the same results. But what's definitely the best way is when we can use the cumulative. And so it's going to actually add up all these. It's going to go from 0 to 2 for us. So I can actually, in one stroke, binomial, cumulative distribution. We have 6 die. The probability is 1/6 of getting our 5. And we're going from 0 to 2. This always goes from 0 up to the value, okay? This will also give you the 0.9377, okay? So 3 different ways of getting there. And I want you to be able to use all of these different techniques. Let's do one more problem, though. This is this function works easier when you're going from 0 up to some value like 2. So I would like to do one more example where it's not. In this case, I would like to find the probability of at least 4 or 5. So we're starting at 4, going on up. So let me just erase just a little bit of this. Maybe we can keep it there. I'd like to use this. We could, of course, write it out this way. We would start off with 4, 5, and 6, right? And same here, we'd go 4. Let me write these out. If we were to try to do this problem right here, then the places it would change, this would end up being 4. This would be 5, and this would be 6 and 0. Of course, then this would also become 0. And, whoops, that could be 6, sorry, 6, 5. So that's how we could change that to be to work for that. And then this would be 4, 5, and 6. So, but how would we alter this? And this is a little more work because, remember, this again goes from 0 up to that. So let me write this out here. This would be then the binomial. CDF. I'm going to go, we have 6 die. The probability is 1/2. And we're going to go from, so now this is the tricky part. I want 4, 5, and 6. So then what I'm going to actually calculate is 3. This is the probability from going from 0 to 3, not included 4, 5, and 6, okay? This is the opposite probability. So what I need to do now, or the complementary, this is 1 minus that, okay? So I really want to point out how, again, see, we didn't put in a 4 here. We went from 0 to 3, and then by doing 1 minus that, it's going to give us 4 through 6. All right, I hope that helps you out.